Good afternoon, everyone. Thank you for turning up. This is great. I was expecting no chairs to be full, so thank you very much for that. My name's Simon Pamplin. I'm the EMEA Technical Sales Director for Silver Peak, and today I want to talk to you about software-defined wide area networks and why they are what I consider the future of wide area networking. So a couple of things first of all. We've got a competition on our booth, as do most people, and you'll see a sheet of paper on your seats. Your job is to work out the answers. My job is to remember to tell you the answers during the presentation and not forget them. So I apologize if I do miss some, but I'll try and keep to that. And we have a couple of giveaways on the booth, depending on who gets it right. So before I start, can I just see a show of hands? Who here has a wide area network in their business? Excellent. And who here is a big fan of cars? I know it's slightly off the wall, but cars, okay. So I was at the Goodwood Festival a couple of weeks ago watching all these wonderful old cars, and I was fascinated by the fact of how difficult it was to start these cars. That you had to adjust all the timing, you had to get the gas right, you had to, the pedals were in the wrong place, and they needed specialist training to do it. Now I get into my car, I push a button, I don't even turn a key anymore and it starts. And the likes of Google have taken that one step further, and they've taken the concept of getting from A to B and simplified the whole thing. It still does route planning, it still does it in the most efficient manner, but they've simplified it such that the application, or in this case the human, gets into the car, doesn't have to do anything, and goes from point A to point B. And that got me thinking. So I remember way back when, with data centers and lots of flashing lights and lots of very highly qualified individuals having to make changes and go to site and do CLI commands to get the wide area network up and running. It was a very long, complicated, in some cases expensive operation. Now why can't that be changed in the way that Google has changed automotive? Well, it can, and that's what software-defined wide area networking is doing today. So hopefully at the end of this presentation, I should be able to have given you some insight into what's possible now to allow you to go back to your data centers and see what you could actually achieve if you didn't have to spend all of your time doing individual changes to routers and networks. So this is where we're coming from with software-defined networking. So what is an SD WAN? So anybody in here already understands SD WAN or understands the concepts around SD WAN? Any hands up from anyone? Excellent. So I was at the SD WAN summit in Paris a couple of weeks ago, and there was a mixture of end users, service providers, enterprise customers, small customers. Every single one of them had a different interpretation of what SD WAN was. Obviously based on the sort of businesses they were and the things that they were selling, but fundamentally SD WAN achieves these basic things. So it's designed to simplify networking. It's designed to make provisioning of an endpoint a very simple but predictable thing. It has to be secure, so what we're doing with SD WAN is trying to make use of multiple types of connectivity. That might be a private circuit, it might be a consumer broadband, so like you'd have at home, it might be a commercial direct to internet, or it might be 4G LTE. It doesn't matter. What we're trying to do is make as much use of these connectivity links as possible. And we have to make sure they're secure. So naturally we use IPsec tunnels, AES 256 encrypted between sites. As I said, we're using multiple forms of connectivity, so it's got to be able to use these multiple paths. So no longer do you have data centers that have an active route and a passive route, where you're paying for both links, but you're only ever using one. In case one fails over, you'll then use the other. What we want to do is make sure that you can use all of the links and therefore get full value for money. And it's got to be reliable performance, because after all, the network is irrelevant if the end user is unhappy with the performance of the application, or the business can't operate because of the performance of the application. So a bunch of fundamental steps, but the main one is that this needs to be centrally managed. It needs to have a single pane of glass where you can see your entire infrastructure, you can monitor it, you can visualize what's going on, and you can make changes, but to your entire infrastructure, rather than having to go to each individual point location. So that's basically what SD WAN tries to achieve. And to a lesser or greater extent, my competitors and ourselves do all of these, but not necessarily much more. So when we start to look at why people are looking at SD WANs, you have to go back in time as to how the WAN was developed and what the WAN was there to do. And typically it was to bring remote locations into a data center where the applications were hosted, their data was then served out to the remote location. So it was a bringing together of all of the data networks. But that's not necessarily the case anymore, because what we've got now is people are using more and more applications that are cloud-based. I mean, I spend my life in SFDC. Other people have access to Amazon Web Services or Office 365. It's becoming a move of the applications from the data center to the cloud. And that causes problems, because the WAN was never architected for that. It was never architected for local breakout to the internet, so everything gets backhauled to the data center and then fed back into the internet, which seems a bit crazy, because every local location has a broadband link, or can get a broadband link, and could go direct to the internet. So it's not necessarily fit for purpose at the moment. One of the things a lot of my customers are telling me is that they've got developers who are developing customized apps for their business, but they have absolutely no visibility of the impact of that app on the network. They just don't know what it's doing. So one of the things that SD-WAN will try and achieve is give that deep packet visibility of what the application is doing to the network. If they want to run it in a test bed or a sandbox, they can then find out exactly what the impact is of a new service to the network before they find out the bad way, when the telephone starts ringing from unhappy users. We all know, if you've got private circuits and you want to do adds, moves and changes, it can be very time constrained and it can cost you a fortune. So we want to try and improve that. We want to make adds, change and moves move at the same speed the business wants rather than the provider wants. And we've got increasing user expectations. I mean, I have 80 to 100 meg broadband to my home. I go into a business, they might have a 10 meg link to the internet. I'm getting better performance at home than I am in a business, which seems crazy. And my cost differential is huge. Thousands of pounds for a private circuit in a business, tens of pounds for a much bigger broadband bandwidth at the home. So as a result, businesses are starting to look at what's the alternative, what's the other way that they can do this sort of connectivity. And as we know, the IT realities is that you're never going to reduce the amount of bandwidth that people want. It's just not going to happen. But there's some key challenges. So you've already got an investment in a legacy WAN infrastructure. You're not going to throw it away. You're not going to rip it all out and replace it. So you need something that's going to augment your bandwidth that you already have and allow you to keep that product going until its natural end of life and you've written it off. Performance and security. I mean, how many times have people been concerned and seen threat management over the internet? We need to find a secure way of making these connections. Application SLAs. Who's going to give you an SLA over the internet? Just doesn't exist, okay? But we need to deliver predictable performance to the end user. So there's a number of challenges that SD-WAN has to overcome in order for it to be an acceptable way of connecting for a business. So is SD-WAN the answer? So we obviously believe it is. We'd be a bit daft if we didn't. And we believe that it has to focus on broadband connectivity to get the cost point round. It has to be able to choose the most efficient path as and when it needs to on a packet by packet basis, so not just a policy-based routing approach where you say this application must use this link. We need to look at all of the links we have and choose the most appropriate one as we see fit. It would be really nice if we could deploy an end device with just plugging in some network cables and powering it on, not having to do any CLI, not having to do any coding. So zero-touch provisioning is another key goal of SD-WAN. Centralized management is key. You want to have a single pane of glass where you can manage your entire infrastructure and react to changes the business needs or react to conditions that need your attention without having to send someone to site. And all of this by reducing the costs as well. So we want to dramatically remove the cost infrastructure that typically a wide area network has taken up. So most of my competitors would say, yeah, SD-WAN's great, it'll do all these things, but we actually believe there are 4 other pillars, 4 key things that need to be added on top of software-defined wide area networking as a base to give you what we've set out as the achievements or what we're trying to achieve. It's got to be highly performant. You can't just deliver a software model that is going to manipulate traffic. You've got to be able to make that traffic go from one point of the network to the other point as fast as possible, irrespective of the network link that it's on. Silver Peak's history in the past is around WAN optimization, so we know that. We've done that for 10 to 12 years. And we have additional licenses, so particularly 2 additional licenses, Boost and Software as a Service, that can be added on to our base licenses to give you network acceleration and acceleration to applications in the cloud. Visibility and control is pretty key, so we look at first packets as they go into our network, and we can determine exactly what we're going to do with that network packet as soon as we see it. And I'll cover these off in more detail in a minute. Security we've mentioned. We don't want to be the next firewall provider. We want to partner with existing firewall providers such as Palo Alto, Fortinet, Checkpoint, Zscaler, and make use of firewalls in the cloud, because that ties in very nicely to the way that we can redirect traffic, which will give the end user a very safe, secure way of doing local breakout to the internet while still going through a firewall. And the extensible, we're linking up with lots of these cloud-based services. So we believe that SD WAN is the core for the solution, but you must, when you go and talk to SD WAN providers, you must look for how performant are they, how visible is the network within it, what do they tie into, and how secure is it? So on performance, I've already talked about the fact that we take any type of connectivity. We can take a private circuit, we can take commercial broadband, we can take consumer grade broadband, so probably the lowest quality link that you can buy, and we have some clever technologies that I'll show you in a minute that enable to us to condition that circuit so that it looks like a private line, but at the cost of a consumer grade broadband. That suddenly opens up all sorts of possibilities of dropping your cost model massively. The high availability, we can determine how a packet should traverse a network on a packet-by-packet basis based on what we call business intent overlays, which are basically a business or application-led policy that we define that defines the amount of loss that's acceptable, the amount of latency that's acceptable for an application, and we will then choose how that packet is routed from point A to point B, depending on the business level criteria that you've set at the top. It might mean that we create a virtual private network that's a full mesh. It might mean that we create one as a hub and spoke. But the system will create that for you based on the requirements for that application that you've stated. That gives us the ability to do predictable performance in the application. And as I said, we can do this optimization in the wide area network with some of the licensable features like Boost. So how do we do this? So we take all of these transports and we can bond them together. So you could take a 10 meg private circuit, a 90 meg broadband circuit, and present a 100 meg circuit. We will then manipulate the packets across those circuits depending on the quality of the line at the time. We can also fail over. If one part of that tunnel fails, or that bonded tunnel fails, we can fail to the other part. If that fails, we can set another condition. So you have complete control over how that network reacts. It may be that you want to drop the packets in the event of a failure. It may be that you've got a voice solution that it's better to have no call at all than a very garbled message. That's entirely under your control. But we have some very clever technology as well. So these are my two favorite things. So forward error correction and packet order correction. One of the ways that we achieve our performance is by reducing the amount of latency overhead. And the way we do that is by continuously monitoring the traffic going through a network. If we start to see, or if the end device starts to see the network getting more lossy, starting to drop packets, we will inject parity packets through another circuit. What that means is that if we get to the situation where at the end point we've got packets 1 and 3, but we missed out packet 2, we can rebuild packet 2 from the parity packet that we sent down a different route. That means we don't have to have the application do a resend. So instantly your latency is cut down. Yes, it does incur a slight overhead injecting the parity because you're using extra bandwidth, but your main packets have gone down their primary route anyway. So you're not impacting the application, but you are reducing the amount of latency. The very fact that you've gone down a different route means that the packets might be out of order. So we do another clever thing called packet order correction. So we sequence every single packet as it goes through our device, which means we know what number it should be, and we can put it back into the right order when it comes out at the far end, be that with the customer or at the application end. So it dramatically reduces the round trip times that keep going on for retries over a lossy network. So visibility. So we, like a lot of people, ingest a dictionary of definitions about what a packet relates to an application. So we will know if it's a packet going to Office 365, we'll know if it's a VoIP packet, we'll know what the destination or the port is, and we can filter how we react based on application, destination, packet type, or port number. And we can then match that with the overlays that we've created. And that's how we control the direction of these things. But it's very important, we do this on the very first packet as it comes into the network. That means you haven't had to allow multiple packets onto your network, who knows what they might contain before you've decided how to route it. It's the very first packet. Do we route it to a known location or do we drop it? So inherently, it's a very secure way of doing things. As a result, we have a bunch of statistics that we can show within the orchestrator that show you the top talkers, the top application, the top locations around the world, what the loss was, what the latency was, all as part of the orchestrator. So you get an awful lot of network visibility purely by deploying our orchestrator and software-defined network. So security, as I said, we build these with 256 AES encrypted tunnels. Our legacy from WAN optimization days was to put everything into a tunnel so that we could manipulate the TCP traffic. It turns out when you do software-defined networking, you have to do it within tunnels. There's no other way of manipulating that data. So we're very fortunate. Our legacy history allowed us to very quickly come into this market and become a market leader. We do have a stateful firewall at the end, which is basically, does it fit a policy or do we drop it? But as I said, we're not trying to be another firewall company. We want to partner with those companies or partner with your company of choice, more importantly. And this is where it links into the service chaining or the extensibility of it. As capabilities appear within the cloud, we are linking up with these people so that we can redirect traffic to their service, be it a firewall or what have you, and we can then make use of their services to protect your data. So we don't have to be a checkpoint firewall, we don't have to be a Zscaler firewall. We work with them and direct traffic from the endpoint to those locations so that you get the best of both worlds. You get a dedicated firewall company and a dedicated SD WAN company rather than someone who's trying to do everything. And what this ends up meaning is that we give you business agility. We basically virtualize all of the network infrastructure and then we apply the business level policies on top of that to determine how we're going to send traffic from one point to the next. And just to give you a slightly different view of this, so for example, in this case, we're looking at a voice overlay. So we're creating a virtual private network secured purely for voice. We happen to have it on a VLAN that we've tagged for voice. We know that this voice has to be a full mesh, and we've got preferred routes on it, which is down the MPLS as the primary route, but if that fails, we want to fail over to LTE 4G, giving the maximum quality. So we can do that, but we can layer up to 7 of these on top of each other. So on top of your existing infrastructure, we can build different networks for different requirements. So as you go up the stack, you might have a guest Wi-Fi network that you want to deploy to all of your locations. You can do that with this model by defining the characteristics of guest Wi-Fi, which is, if the bandwidth is there, great, they can use it. But if the bandwidth is required for other things, or the network link goes down, that's part of your policies to say maybe don't let any packets go through. Or maybe you want guest Wi-Fi to be there all the time, in which case you can change the policy and tell it to use an alternative link. So it's extremely flexible, but you build these layered, secured tunnels on top of each other around your business requirements. We deploy in both physical and virtual formats. We sit on all of the top hypervisors. We find that a lot of customers end up preferring the box or the physical hardware for remote locations where they don't have any technical expertise, because it means they can physically point at a box or they can label it and say, go and check on that box or plug that cable into that box. But we deploy in the cloud, virtual or physical. And these boxes come in various different sizes, and that's based on the bandwidth that they can deal with. So the very small box will deal with up to about 200 meg of throughput. The larger box will deal with 10 gig and everywhere in between. The model that we have is based on the bandwidth you buy. So it's a subscription-based model, so there's a monthly charge. If you go for the virtual device, there's no charge for the software, but you pay a monthly amount for that 200 megs bandwidth per site. As you go up the size and the capacity, obviously the monthly charge changes, and if you decide to buy the box, you have to buy the hardware, but we make no money on the hardware, so it comes as cost, and then you pay your monthly charge. So it's a very scalable and easy to understand model. But ultimately, what does this mean to the end user? And this is one of my favorite slides from our orchestrator. So what you can see here is the lower graph is a broadband connection, I believe. The middle graph is an MPLS graph, and you can see the spiky bits is where we're experiencing loss. The brown parts here is where we've hit a brownout condition, and that's entirely configurable by yourselves in the policy. You state, if I hit this amount of loss or this amount of latency, I want to mark it as a brownout condition, and then I will do some activity or some action. So you can see this in real time on each one of the flows. The interesting bit is the very top graph. That's what the end user application sees. So because of using forward error correction, packet order correction, maybe some of the boost licenses and the software as a service licenses, we can turn these bonded tunnels into an extremely clean, high performance link. Because at the end of the day, it's the end user that matters. We can have the best network in the world, but if the end user can't work, it's pointless. And we see this in real life. These are some of the sort of capacity changes that customers are seeing that we have. So the light blue is the traffic that's on the LAN, the dark blue is the traffic that we actually sent over the WAN, and in this case we were doing some of the boost licenses, so we were optimizing the traffic. So we'd seen some of the traffic before, so we were able to do data deduplication on it. And as you can see, dramatic reduction in bandwidth to achieve the same end. Does that save you money directly? Not if you've already sunk the money in the infrastructure, but it does mean that you can do far more with your existing infrastructure and save you having to buy extra bandwidth or more circuits. So it's an extremely good case. We have one customer that has gone from a blend of MPLS and broadband, and they're a global manufacturer. They have places in China, Europe, North and South America. They've now moved to broadband and broadband only. They run voice, they run SAP, they run CAD, they run Office 365, local breakout in every region. Their cost base has gone down by 90%. Their application performance and customer satisfaction is exactly the same as it was when they were running on private circuits. So we have proof, we have case studies that it does work. And pretty much this is what they're seeing. So you start looking at the metrics, because you can blend this how you want. If you went to the nth degree and decided that you wanted to go broadband and broadband, and this is consumer grade, we're not talking direct to internet, which obviously is slightly more expensive, you can achieve these sorts of cost savings. So if anybody is now interested in SD WAN, we're over on booth J12. You've got your competition entries. I hope I covered all of the questions in there. If I didn't, I do take bribes outside, so quite happy to do that. And thank you very much for your time. Has anybody got any questions? Yes, sir. So the question being, is this the end for MPLS? So MPLS has still a long life in it, but it will naturally tail off. We are starting to see people moving away from MPLS and looking at alternative connections because of the cost basis of these things. The very fact that we can achieve this now means it's possible to look at alternatives than private circuits, but I can't see that happening in the next 5 years. 10 years out, who knows? But it's certainly possible now. Any other questions? Okay, if you need to have or want to have a chat with myself or any of my colleagues, we're all over on booth J12. Be more than willing to sit down and go through it in detail as to how it works. But thank you very much for your time.